start recording here. Cool. So welcome to our second meetup, and just to talk about some housekeeping, everyone should have their first assignments graded, and let me know if that's not the case. But everyone should have theirs returned and graded. And overall, it was a great. Great batch of assignments, so I think everyone did really well with these questions. And we'll go over sort of a few potential solutions, and I'll touch on sort of what some common mistakes were and how to deal with those in the future. So before we do that, however, I wanted to go through Module 2. So basically, for Module 2, actually, as one of the students emailed me, previously I had accidentally left a version of this with the answers, so I had updated that early over the weekend. So it should be updated now. However, there are still a few issues with the notebook that was making it not run right out of the box. So has anyone taken a shot at looking at the notebook yet, and possibly noticed some issues with it? So basically, there's oh shoot, and it was in the chat. So basically, the one of the things that happened was there was a change to the data format. It's released all in one CSV now. So if and actually this was a version. One of the students from the previous section had found so this is version 17, but what this is, you'll see it's version 18. So the version 17, I'll post a link in an announcement, or actually, I'm sorry, what I'll do is I'll put the link in the notebook itself. So I'll make changes here. And there were two things that happened with this version, with the new version of the data. First of all, everything was in the same CSV, but also all of the column names were changed. And it was literally just changed from uppercase to lowercase. So if you guys were if anyone sort of took a look at the notebook, there's a chance that you may have figured that out and began accounting for that. But in case you haven't, I'll provide the link for the old version, because actually Jupyter doesn't have a global find and replace, which is really annoying when having to go through here. So I'll try to make sure that all of that makes sense. And I also, in the previous section, there were a few students who were having issues with installing some of the packages, or just with Jupyter on its own. I was told by one of the students that when she had taken 602, which goes through Python, it was Spider that was used as an IDE rather than Jupyter notebooks. And I don't know, if something like that was like a recent change or what. So for everyone here, in 602, have you been exposed to Jupyter notebooks? Either also comment if you've been exposed to Jupyter notebooks elsewhere. So Gabrielle mentioned it was in web analytics, so data 620. Asher, yeah, it looks like you didn't get that in 602. So yeah, Jupyter. I presented the assignment in Jupyter notebooks. I find them a very useful way to sort of get kind of combine code with sort of more narrative style. So looking at being able to add a lot more content than you would be able to in the comments of a file. If there's so basically, I'll just go over sort of a few you know basics of what Jupyter does, and if you guys have any questions, then if there's first of all an issue with just opening up the notebook, simply accessing the notebook, that would obviously be a something that you wouldn't be able to get past. So let me know if that's the case, and I'll sort of try to make a change as to the content. I'll sort of provide this in a .py file, so you'd be able to open it up in Spider or in PyCharm. And otherwise, if you're just more comfortable in those IDEs, absolutely, like what, and you're comfortable enough where you would rather just copy and paste what's here into into Spider or PyCharm and work there, that's absolutely fine. So if you, rather than submitting a notebook, if you submit a Python script, that's totally fine. But what I would ask is if you kind of treat it like it's a notebook. So sort of provide in the comments instructions for how it should be ran, because these, no matter how you're working on this assignment, I would say it's not really meant, just for one script to be ran. It's sort of meant to kind of step through, if I get a .py file as a submission, I would go through sort of, I would step through the individual lines. So if so absolutely, it's fine to use an IDE. Just try to sort of use comments to really guide me through grading it. So with that should be fine. And then there's and then just in terms of the libraries themselves, I assume most people who are who have Python installed, they're using Anaconda, and so and I sort of I use pip myself, so I had mentioned pip install Shapely for this library here, Shapely geometry, and but rather than using pip, you could just replace that with conda. So if you see, I think that's the only place where I mentioned pip. So just keep that in mind, that if you're using conda, just use conda install. And I had this, like if you just Google conda environments, you'll get to this page. Anaconda has a really this is some really good documentation in terms of dealing with environments. And the reason why I mention this is you may not even face sort of friction here if you have with Anaconda, and especially using Anaconda in more of a data science sort of local ad hoc workflow. Odds are you have one or two master environments. You might have a different environment for Python 2 versus Python 3, but odds are you're using sort of that master environment. So basically you just install packages to that environment. When you start Jupyter, odds are that environment is going to be what kernel you're using. But if you are running into issues where you think a package should be installed and it's not, then you're able to go here, change kernel, and go to the kernel that that you would need to use. So I have a lot more here. There's you would probably have just one or two, but this is where you would sort of make sure, like, this should match whatever you would have within either your terminal or command line to run a file, in a specific environment. And with Conda, it should be managing the kernels with Jupyter. I remember when I had Conda installed, I didn't even have to think about these different, these different environments. But there is so there's a page here where not Ansible. Here, this is what I was looking for. So this post here, and I'll if anyone needs this, I could send the link to you guys. But basically, this just goes in to the case where if you're not seeing your environment here, this goes through how to get your environments associated with Jupyter. And in particular, this guy is using virtual environments rather than Conda. Don't worry too much about that. So this translates to if you're using Conda very, very cleanly. And what really matters is this IPy kernel. So you're installing the IPy kernel library, and you're using this to essentially associate the kernel with Jupyter. And what that tells Jupyter is it gives it information about where to find the path, where to sort of find that environment, and it'll then add it to your list of kernels here. So if anyone's having any issues with environments like that, you could get that set up. Asher asked, are we using Python 3 and does it matter? I'm using Python 3 for this, and I don't actually. I think with some of these libraries there may be some weirdness that happens with Python 2. There might not be. So and there's nothing else in the code where it's Python 3 specific. So as far as I'm aware, it should work fine in Python 2. If that's the environment that you're using, just use your Conda install. But I would given the choice, I would use Python 3. Cool. Any other questions on that? And actually, so I'm going to have to change some, I'm going to change the link to the Pluto data. So I should get to that either tonight or early tomorrow. So look for that to change so that this notebook runs more out of the box. In particular, the newer version, it has these in lowercase, so it's really annoying to have to make all of those changes. Otherwise, it should run out of the box. So, and again, if anyone has any questions on that, just mention it in the chat. And so in the notebook itself, there's in addition to sort of bringing in the data and a few, there's sort of a few sample graphs and some. I sort of provided a cheat sheet of pandas for I know that the program itself really leans on R more so than Python. So you guys may not have as much experience with Python as you might with R. So I tried to provide this as a cheat sheet to really, and I'm using sort of dplyr syntax here to make the comparison of in an R data frame where you have things like dplyr group by, you have also a concept of group by in pandas. So I sort of mentioned some tips and tricks in terms of pandas, and then there's also a book I recommended, sort of a cookbook style intro to pandas. That you should be able to find out there. So the data that we're using for Module 2, and what I'll do, by the way, just for the meetup, I'll go over Module 2 and then we'll sort of go back to Homework 1. And if we have time, I'll go through a few content slides that I have. But for this second assignment, the data that we're using is what's called Pluto data. So it's essentially it's data about every single tax lot in New York City. It has I believe it's about 800,000 data points. So while it's not yeah, it has about 800,000 data points. So while it's not, truly big data, you're able to deal with it in memory still. We're not having to use any other technologies for that. This is still big enough where it will affect, choices of visualization. So one thing that I think it sort of makes sense to take a look at here. This is this is sort of a tool that's integrated with Plotly called WebGL, and this page gives a lot of information about getting examples of plotting graphs with on the order of 100,000 points, on the order of 1,000,000 points, and you're able to, or sort of very dense line plots like this. And these are sort of meant to show that it's possible to plot these large numbers of data sets, but it's not really useful as a visualization. So looking at exactly as Gabrielle mentioned in the chat, just because it's possible doesn't mean you should. You have something like this, and you kind of get an idea that it's normally distributed, but once you get close enough to the center, you're not able to really see a difference between the density of points up here versus the density of points in the center. You could kind of arrive at that if you zoom in. You could get more information on the distribution. So now we have a clearer idea that things are slightly more sparse out here. But this still isn't the best way to deal with a large data set of this type. And really the strategy for dealing with these larger data sets is to think about what you want to show in a visualization and use techniques such as binning and aggregation. And that's what part 1 of this module is meant to go through. So it's and as I sort of mentioned in the text here, you have visualizations where the visualization types where aggregation is baked in, something like histograms or 2D histograms. They're all you're setting your bin size, for example, when you're making these visualizations, and it's something that's really baked into the visualization type. But there's also you could use any kind of visualization type with aggregated data, and also arrive at successful visualization. So for this data, what we're looking at first is trying to see how we have every tax lot, we have when the building was built, and we want to get some idea of like essentially when buildings were built over time. And so we're using group by, we're just grouping by year built, and we're here in terms of our of what I'm counting, I'm using the BBL column, which is good to know for this data set. It's a unique key. It's borough, block, and lot number, I believe, and it gives but basically it gives you sort of the combination of borough, block, and lot number is a unique key. So BBL is the column that you would use there, and so what I'm looking at here is I'm looking at year built. So I have this sort of group by year built index, and then I have the actual count column. And I end up with something that looks strange. So, I group these buildings by year, and we have something that looks spiky. That looks like this. So, does anyone have an idea of what might be going on here? So what we have some years you'll see kind of thousands of buildings being built. Here we get back into low thousands rather than tens of thousands. In some cases, we have sort of in hundreds in some years, and then sort of spiking up to again on the order of tens of thousands. So another question we could be asking is, do we think this data is entirely accurate? So do we really think that in 1949 there were 749 buildings, and there was just a building boom in 1950 that led to 47,000, and then things got back down to 757 in 1951? Yeah, so Gabrielle mentioned some might be, some of the spikes might be accurate, but it's not really enough to warrant its shape. Um, the so so yeah, what's yeah, so Asher is uh, is noticing that there shouldn't be any reason why the data collection should be clustered around those years. Um, so so Asher, you're kind of touching on it here, where what we are, what it seems like we might be dealing with is a data cleanliness issues. And yeah, Gabrielle, that's you're getting warmer with that. That it's about every 5 years that we're noticing a spike. And so in 1945 we have a spike. In 1940 we have a spike. And what's actually happening is this is basically pointing out that the data isn't as clean as it should be. And what's actually happening is you could sort of glean this from when you're looking at the later data, you end up with a smoother pattern, and you could kind of glean this by the fact that these spikes are just so much higher than what you're getting in the cleaner pattern here, that basically with older buildings, perhaps there's not as much information about these older buildings. So here it looks like the cutoff is around you have a spike in 1980, so it's like 1982 or 80, yeah, you could sort of say 1982, I guess, where things begin to, or maybe even 1984, 1985, where things begin to get smoother. And so what's happening is, we have accurate data for more recent buildings, but we don't have them for older buildings. And this kind of makes sense. When the data that we're looking at, it's looking at every lot in New York City. So there's a lot of obviously showcase skyscrapers, but if you're really looking at what the majority of lots in New York are, they're smaller buildings. They're sort of small walk-up apartments, a lot of single-family homes, a lot of sort of one or two family homes. And there's if there's a smaller, less sort of historically significant building that was built pre-war, or sort of 40s or 30s, whenever it was built, it may not be known what exact year it was built, but there's enough information to place it in either 1930, 1935, and this could be due to any number of factors. It could be that data collection was just done, maybe similarly to censuses, where censuses are every 10 years. It could have been done. There could have been building census, a building census perhaps, or it could just simply be best guesses, perhaps based off of whatever information they had. Asher was asking if we have any info on how this data was collected. If you go to the nyc.gov site, there is a data dictionary which goes into a bit of like in the PDF, it'll go into a bit of sort of the limitation with the data here, and there's a few. I don't remember the exact site, but and that's, yeah, I'm getting a lot of Pluto stuff. I'll try to find if I find another. There's a blog post that I remember that really goes through what sort of why the Pluto data set is so messy. So that would be sort of use there also. But there should be some information of that in the data dictionary. And so there's the so yeah so there's data cleanliness issues basically. So in addition to dealing with a larger data set and having to use aggregations in order to sort of more correctly show the patterns underlying the data, there's also issues with sort of dealing with unclean data. So you guys will have to be working around this as well. And so part one is focusing on the on binning and aggregation. And one thing I kind of wanted to just note about binning and aggregation, most of the time it doesn't make sense to make a plot like this, where you're just sort of throwing everything in a scatter plot. But one key point that I would want to make with these larger data sets is if if you still want to expose some information about individual data points, and there may be reasons why you want to do this. So, a common reason might be you have sort of a large data set, and you want a visualization to highlight anomalous data. So perhaps to highlight outliers, and an example here. Unfortunately, the interactive version of this isn't working, but so we'll have to sort of cheat and get what we can with this screenshot. But this is an example of what I think is a successful visualization that's still using a very essentially like a scatter plot for a large number of points. And so why do I think this is successful? So what this is looking at is essentially strategies of portfolio optimization. And so it's because of the subject matter that I think this is a successful visualization. So this style of optimization, I won't get too much into it, but you basically have mean returns on the y-axis. You have risk, which you could think of as just standard deviation or variance on your x-axis. And the idea being you have sort of a lot of hypothetical portfolios. And by portfolio, we just mean collection of individual, stocks, bonds, any sort of investment products. And you have a bunch of these portfolios. A bunch of these portfolios give you some sort of mean return, some sort of variance. And the goal is, you want to choose obviously you want sort of the best portfolio for what you're looking at. And in this style of optimization, there's what's called an efficient frontier. So in an ideal world, you want to maximize your mean return. You want to minimize your variance. So you and so that's sort of the goal that you want. And with that sort of goal, it leaves the question of optimization a bit open-ended. You may have one portfolio where there's a high return but also high risk, another one where there's a slightly lower return but it's a lower risk. And the question of which of these two hypothetical portfolios is best isn't it comes down to what's your risk tolerance. Are you willing to risk sort of higher average returns with the chance that you may get negative returns in some periods. And but given that, there is still a what's called an efficient frontier. So there's sort of you have sort of an edge to the data. So you're not able to sort of increase your returns without making further increases in your variance. You can't just sort of end up kind of at a point out here outside of this frontier. And basically what this means is you want to be somewhere on this frontier. So a portfolio that's somewhere in the middle, it's, you could, and like if you think of this conceptually, I have some sort of risk here. I'm at this portfolio. I could switch to this portfolio and get higher returns with the same amount of risk. So, you could say objectively that portfolio is better than this portfolio. But if you're trying to compare this portfolio to another portfolio on this frontier, that comes down to what your risk tolerance is. And basically, the shape of this, really allows it to work as a scatter plot. And that's I want to highlight this as an example, almost a counter example to how you need to deal with larger data sets like this. That while most of the time you're going to want to aggregate, bin, find some way to deal with it in that way. Sometimes if the shape, if what you're interested in is either something that's an outlier or anomalous, or in this case, something that's along the frontier where users would be able to highlight, and find out what portfolios are along here. So that's something, just something to keep in mind when you're dealing with larger data sets. And so that's sort of a caveat there, the exception to binning and aggregation. And then the second part of this homework is going through a library called Datashader. And Datashader is essentially something that smartly deals with these questions of aggregations, and dealing with larger data sets. So the example I give here, we have sort of a 2D histogram of year built versus number of floors. So I want to get sort of a summary visualization of these two variables. And if I were to plot it out as just sort of naively like a scatter plot, I would end up with large. First of all, there's a lot of buildings that are shorter, a lot of lots that. So I have a large cluster that's here, and it would be sort of harder to really gain any insight with just a naively built scatter plot. But looking at this, you could sort of see, we have individual binned cells, and we're able to say, and I didn't really deal with dates in a smart way, but you could sort of look at buildings built in 1904. We have sort of one building here. We have 21 buildings that are 18 stories and are located here. So this shows us, distributions, but Anaconda has a really nice, which I actually had already opened here. Anaconda has a nice sort of example of these different, what they call plotting pitfalls when dealing with large data. So, looking at this first example to get an idea of the sorts of pitfalls that they're highlighting. Here we have two categories. We have blue and red, and we have these two examples where, in one, we're naively plotting red first and then blue, and here we're plotting blue first and then red. And it's the same data, but C and D end up looking differently. And, you could see this as really, a form of misinformation in a visualization. So both of these aren't really communicating what the actual, combined distribution is. And one strategy of dealing with it is in a small multiples way. So if you were to show A and B, that's a great strategy of sort of looking at it. But sometimes, if you did want to put it on the same plot, like, you need to somehow deal with this. There's a few ways, that you could sort of do this with existing tools. So opacity is one way of doing this, where you are able to, almost to a degree, see through points and get sort of an idea of where there's, so here the effect isn't as pronounced, but it is still kind of there. You still have a bit more blue here and a bit more red here. So it's not perfect, and it's still not giving us an accurate picture of what's happening. And this goes through a lot of other examples of what might be happening with these larger data sets. And what Datashader does is it's an algorithmic way of dealing with these sorts of problems. So taking this same question of looking at year built versus number of stories, if I put that into Datashader, I end up with a plot that looks like this. So it's smartly dealing with my, sort of dense areas of points. You could see it sort of it uses a color scale to communicate where there are denser areas of points versus less dense areas. And this kind of gives you the best of both worlds. You have, for the sparser regions, you're able to view that as individual points, giving you slightly more information for those regions. And for the denser regions, you're not getting overplotting problems. You're able to sort of get information about this being more dense of a region, for example, than this. And then, the example I gave here was Datashader, really shines with this sort of geographic information, where it almost gives you the same thing that it's doing for, like, making a 2D, sort of looking at a 2D histogram and translating that to a scatter plot. It sort of makes a, what originally is, just points on a map, and almost makes it into, you could think of this as a form of a choropleth. You have, in this case, it's just coloring by density. But in a few of these examples, especially the U.S. Census example, that'll show you how to deal with things like categorical variables. So that's that's what's showing up here. This is just mapping everything and showing where there are dense areas, which counterintuitively, it's actually not in areas like Midtown, because if you think about it, you have a taller building, it's going to have a wider lot, and so as a result, there are fewer lots. Where you really have density of lots are in sort of your brownstone neighborhoods, where you have more closely packed sort of single or one or two family homes. So and to get into the questions, actually forgot to do that for the first one. For the first question, we're looking at investigating older buildings for safety. So the way that we're sort of characterizing this is, we have ways of binning buildings, so things like 20 to 29 story buildings, 30 to 39-story buildings, and we want to find out when these buildings were kind of first being attempted, because if you think of it, as technology increases, we're able to build taller buildings, but those first few buildings that we're building at those heights, it may be using untested technologies, it may be or methods, and we're sort of running with the hypothesis that we want to check these older buildings and see what might be happening with them. So that's what we're aiming for with that first question. And then, Asher, to touch on your question, there is a geographic identifier in the data. And I actually, so there's this here, it provides this what's called X chord and Y chord. And what I actually did here was translate that into longitude and latitude. And there's not, like, I don't get too bogged down in what exactly this is doing, but just to give a sort of broad overview, this is sort of like, when you think of different map projections like Mercator versus others. For some reason, I'm not thinking of others, but you have different sort of global projections that try to accurately project a spherical Earth onto a flat map, and different strategies about doing that. What these coordinates do are, when you're dealing with smaller areas, it's you're it's easier to, with a smaller area, to project just a straight grid, and you're like, as long as you're dealing with sort of on the order of New York City, so on the order of the 5 boroughs, you're not going to get too much distortion by just assuming a sort of flat grid. You do end up with more distortion as your area gets bigger and bigger. So there's, in addition to global projections, there's a lot of projections that are locale specific, and there's some sort of origin, and with that origin, it's meant to be used in a smaller geographic area. So as you get further away from the origin, things get more and more distorted. But as long as you're dealing within a more compact geographic area, you're able to use that. But I provided this here to translate it into latitude and longitude. And if you actually, I had realized this after I went through all of this, that I could have just used the X chord and Y chord. So yeah, Asher, that's the geographic identifier in the data. And for the question of the second part, because this is meant to really be highlighting what Datashader could do, this is focusing more, like, it's pretty much, I'm giving you like what method to use, and it's just sort of use Datashader to achieve a specific method, achieve a specific, sort of, like, I'm giving you sort of what to do. The goal is just, find a way to do that in Datashader. And so what I'm asking you to do is sort of use a very unique style of sort of displaying data. So in this case, this is what's called a bivariate choropleth map, and it's essentially a strategy of, you have 2 variables, and you want to map both of those variables. So here, for example, you're like, this is sort of an example where you have population density, and this is actually a problem with mapping, where if you map something naively, you may just be getting a population density map. If you're mapping murders, for example, you'll end up with more murders in cities than outside of cities just because there's more people there. And so this is sort of a way. In this case, this is looking at Bigfoot sightings, and it's looking at reported sightings versus population density. So you're getting kind of where you have high Bigfoot reportings, but lower, sort of more sparse populations. You have different regions where you have rare sightings here, you have lots of sightings, you have these two areas where sightings and population are sort of following track. And we're using this to look at in the Pluto data. We have essentially these tax assessments consist of two parts. There's the value of the land and the value of the structure on the land. And so in this case, pretending we're a real estate developer, and we're most of the time there would be a correlation between land and structure value. If you have very valuable land, you're going to want to put a valuable structure like a skyscraper versus a single family home. And what we're looking for are sort of patterns in this. So as a developer, you want to take regions where land might be underdeveloped and make sure that it's properly developed. Or if an area, essentially you're looking at where an area could stand to have more development. And so in this case, we're looking, we're using the bivariate map, choropleth map strategy here to compare these two measures. So, all of that is laid out. The color scales to use, like they actually list color scales right here. Just use one of these and find a way of plotting something like this out. So, using another example of what you could do, this is looking at census data and plotting it out by race. And so this goes through a few examples, but so you have some sort of single variable shaded where we're just looking at population density maps. And then we're adding categorical data. So here we're looking at at a map of all census respondents by race, and so it gives you some pretty neat visualizations like this. So it's as you zoom into cities, you're able to get obviously more context of what's going on versus a larger map, which is just sort of showing that rural areas have mostly majority white people living there. So so we have this, and Asher, when you say choropleth, are you referring to these choropleths over here? Both. So there's so basically to build actual choropleth maps, there's a few ways to do it, and actually what I've been finding recently is a few newer. There's sort of essentially like I found kind of we're in the beginning of more custom choropleths being brought into R and Python environments. With R, there's this was added to ggplot, but it's what's called geom_sf, and geom_sf is essentially a way of looking at these sort of custom geographies and ending up with, so here, for example, we just have 3 counties, and you could sort of choose what you have there. You upload it in what's called a shapefile. There's sort of examples like this. On pages, this is using data shader. So because data shader is smartly clustering all of our points and solving our plotting pitfalls, it functions in a way like a choropleth map. And actually, um, yeah, I don't know if I would explicitly call this a choropleth map, but it's similar. It is kind of similar to a choropleth, but each of these are still individual points, and it's the data shader algorithm which is shading it to give us something that looks like this. Using a strategy like this is going to be what you're working on for the second question here, and then to just sort of talk about other ways of dealing with choropleths. You have in R you have geom_sf. In Python, there's I'm not aware of something that is as easy as geom_sf in Python yet, but as I've mentioned, like I know at Plotly we're working on it, and but we're not there exactly yet. But I think we're sort of reaching the point where you would be able to take sort of a shapefile and a shapefile is basically sort of information about like the county line drawings. Like this is contained in what's called a shapefile, and there's an increasing number of options out there I've been finding that are allowing people to more easily create choropleth maps like this. But aside from this, you have also your libraries like Leaflet or Mapbox, where you could add a choropleth sort of layer on top of, and then there's with D3 you're able to. With D3 you could do anything, but there's choropleths are also sort of just having the line drawing. You're able to get that with D3 as well. I believe this guy is using Illustrator even. Yeah. So that should be it for the second.
I can't talk. I can't type fast enough to ask the question.
Uh-huh.
But with the Joshua, I think it was the Joshua tab that you have.
Yep.
Um, that that map was produced in R Python.
I'm not sure. I even think he
Okay.
was. I think he might have even been using.
Oh, Windows Illustrator kind of thing. Is that what you?
Yeah.
Okay. But
So
normally with a pleth, is that right?
yeah.
Map like that, are they using, for instance, like FIPS codes as the unique identifier, and then the package in either like R or Python or whatever knows to read the FIPS code, or is it something else that?
So in a map like this,
Mhm.
it's using like these are just counties.
Yeah.
So like the data that would be input into this is either already aggregated data about counties, or it would sort of be like, let's say like this census data. It's
Hmm.
essentially looking at individual reportants, and like people who report into the census, and it's plotting essentially with each person there is a latitude and longitude,
Oh
and
wow.
yeah, so
Oh,
all
I
this
see.
is
Okay, that's
yeah.
incredible.
Mm-hmm.
So that map must take. Does it take quite a while to produce? I mean,
Actually, with Data Shader, it takes surprisingly.
just a few
It's
seconds or something.
Yeah, exactly. It's not that.
Wow.
It's pretty well optimized in terms of that. And
So with that data shader, and this is in Python now, right?
yep, Data Shader is
Okay.
Python.
And that's using longitude, latitude, so you could do that for any country, any place as well.
Exactly.
Wow.
So something like this it's a pretty strong library. The only caveat being, if let's say you had information like aggregated by zip code or by
Yeah,
county
that was my
FIPS.
next question. Yeah.
Yeah. If you had data like that and you were to just naively put it through Data Shader, you
Hmm.
probably wouldn't end up with the best data or with the best visualization, because what you'd probably end up with is a point in the middle. Like if you were to sort of
Yeah.
choose what latitude and longitude you're going to associate with each point, you would probably choose like a point in the middle of the county or in the middle of the zip code, and you would, essentially end up with kind of, um, you would have multiple points with the exact same coordinates. So that wouldn't really,
Hmm.
essentially you would have these individual points that are colored. And, when you're dealing with that, like having a choropleth where you actually have a polygon to fill in is the way to go. But because we're dealing with individual, we're dealing with every lot in New York, like this lends itself really nicely to data shader.
Oh, I see. So if it was, is there a package that you know of that works well for other countries, or is that on a country to country basis? So, for instance, with I'm working on this project concerning Bulgaria,
Uh-huh.
and I have data, I think, on the region
Mm-hmm.
basis. Um, do you know if there's a package out there that has that is well suited to a project like that?
Not that I'm aware of, and sort of the way that you would have to deal with that, because like, and this is why choropleth style maps
Hmm.
it's like a harder problem than other visualization types, because what you need is the information about what your geographic boundaries are.
Right.
So
Right.
there's uh, so um, so you could either use what are called GeoJSON or shapefiles,
Hmm.
and GeoJSON is just the more uh, kind of programmer friendly version of that. Like shapefiles are meant to be brought into GIS systems, but the I'm trying to find a quick like example of here. I think this will give us. That's meta, and these are RDAs, but I want the actual JSON. And I'm not. Yeah, I'm not
Hmm.
finding. Actually, let me. We have an example, I think, that draws. So right now, like this is kind of not the best because it doesn't really give the full interactivity. But what it does is over what's called Mapbox, it displays data. But basically, what you have to do is you have to retrieve that data. So actually, the um, so here, for example, um, we're looking at individual counties like this, um, and you need to bring in the oh, so yeah, that's right. We recently added this where the FIPS, the counties are actually built
Hmm.
into Plotly choropleths, so that's a nice sort of automatic one. But so basically what you'd have to do is the find the shape file. So here there's a um, oh, and we updated all of these. What I actually want is yeah. So here, this is sort of the old way that you used to have to do this, and basically you have to get like a separate JSON. So we have linked to the thought this linked to yeah. So there's so basically and it looks like the link was removed here, but we used to link to it was like a site where we got the shape file, but
Hmm.
to just get an idea of what a shape file looks like. it looks something like this. So you have sort of your what are called features, and that's a list. And then you have your different types of geometry. So like most of it's going to be multi-polygon. You have your points which sort of trace out the polygon, and then you have the properties of it. And
Oh, I see. I see.
so what you'd need to do is you'd need to find
Right.
a GeoJSON of the Bulgarian regions, basically.
Right. That's interesting. Okay,
Yeah.
cool.
And then once you have that, there's you could use sort of this example here, which is kind of a bit sort of roundabout, or you could use sort of leaflet, Mapbox, etc. to sort of do that, or in R you could use geom sf.
Geom SF. Okay.
Yeah, it's geom underscore sf.
Okay, cool. Thank you so much. That's awesome.
Yeah, no worries. Um, and we're approaching the end here. I did want to quickly go over the homework here. So, so yeah, just to quickly go over the homework here, um, uh, the submissions I got were mostly, were mostly great, and I, just wanted to go through a few strategies of dealing with this data. So we have, so basically for the first question, we're looking at companies by state. So we want to get, a count of companies with each state. And the trick here was, or not trick, but the one of the constraints here was the visualization should make sense on a portrait-oriented screen. So that was one thing to keep in mind there. Most people got this one, that it's bars that is best for this sort of categorical comparison. But if we're looking at bars like this, like if you imagine stretching this out for a portrait, it wouldn't really look too nice, stretched out in that way. But what works better is a visualization like this. So here we're using chord flip to get a horizontal bar chart. And in addition, I used this just reordering by state. So it allows us to very easily answer the question that the state with the third most companies is New York. And then for question two, and type questions if you guys have them. I'm just trying to breeze through this a bit more quickly than I would like. But the for question two, the we're looking at the distribution within of companies within industry. And here I was a sort of focusing more on sort of what that distribution is, rather than it's not just a simple aggregation, so not just a count, not just a mean or median, but more trying to get an idea of what the distribution of companies are. So here, first brush, and this is always a good way to start, is just plot it out on a scatter plot. And we first notice we have some outliers that make it very difficult to make any sort of conclusions about the distribution of employees within sort of the vast majority of these data points. So we need to find a way to deal with that. And what I ended up doing was clipping the data, but there are other methods of dealing with outliers. So I'll sort of mention what a few other students had done. But first, sort of looking at this, we clip out our three main outliers here, and we set a sort of limit at 2,500 employees, and we end up with something that allows us to see the distribution of companies way more clearly. And the so one thing to sort of note about what this data looks like is it does still look like we have outliers, um, and what seems like is happening is this is kind of an exponential distribution. There are like statistical methods to try to, if you're assuming the data is exponentially distributed, you could find out sort of what that distribution is, like back into that with the data. But a rule of thumb I sort of like to use with trying to find out what the distribution of the data is if you cut off outliers and you still have outliers with sort of your clip data, then there's, and here you could sort of see that's the case. Like if I were to make my cutoff 500 companies, or 500 employees rather, I would probably still end up with a few outliers. And you could kind of see that, like these guys would be outliers and I would have a similar problem. Um, I think this works. This works okay. We're still able to see the distribution. So I chose to use this, but what some students had chosen to use here was a log scale instead of clipping this. So and a log scale, it's totally a valid way of doing this. It totally takes care of outliers for you. You don't even have to worry about you know cutting them off. So it deals with that, and it also deals with the or I'm sorry, the one drawback of using a log scale is it's a bit less intuitive. For it affects readability like slightly. Sometimes so for example, and this is tying back to our meetup last week or 2 weeks ago. When you're looking at length, or in this case just position on a grid, you're able to pretty easily see that this company has twice as many employees as this company because it's twice as far along the x-axis here. But when you have a log axis, you sort of, it's essentially just one extra step that a viewer would have to take in looking at the data. A lot of times it makes sense, and for this assignment, it's definitely something that works. But just for this, I chose to clip the data, and then what I added here was just what's called was just adding a box plot rather than looking at a scatter plot like this. So here, this gives us a cleaner way of viewing these distributions. So we're able to see all of our medians and get an idea of our interquartile ranges. And lastly, just labeling those outliers. And then for question, and then these are just a few more creative sort of creative ways of custom ways of dealing with these sorts of um, distribution style questions. So here we're actually looking at the mean rather than the median, and we could choose whatever measures we want. So for here, I'm using just standard deviation, and I sort of made my own custom way of dealing with distributions. The cool thing about this takes care of the outliers for us as well. Um, and this is very similar, but just looking at error bars on top of a bar chart. And then lastly, for question 3, this was looking at a different metric, but it was a very similar style question. So basically, I sort of first looked at it with a box plot, and then this is just sort of one more strategy of dealing with these sorts of distributions. So this is using what's called kernel density plots. So kernel density plots, it kind of takes it sort of builds a continuous distribution out of discrete data. And it just gives you that much more information about the distribution. So with your box plots, you're able to get an idea of, how how sort of you get sort of a good feel for variance. But with these kernel density plots, as an example, with the real estate industry, we're able to see that there's kind of a bimodal distribution, and that's something that wouldn't show up in a box plot at all. So this gives you slightly more information there. And these kernel density plots, these are actually what's also used in what are called violin plots. So violin plots, you sort of have the these reflected on each other, and it's a sort of sort of play on box plots. So I sort of got through that a bit more quickly than I would have wanted, um, but does anyone have any other questions on the first homework? Cool. Cool. So I'll save the slides I wanted to go to for next week. And it was just sort of some quick content I wanted to go over, but we sort of used up all of our time. So yeah, the next homework is just due on Sunday, and I'm looking forward to seeing what everyone has made out of this. So I am going to be making some changes so that this could run a bit more out of the box. So look for that. I should be able to get that live tomorrow. And but otherwise, good luck um, and thanks for coming to the meetup today. So I hope everyone has a good night. All right. Good night, everyone.